for number 25, I'm starting with the worksheet that's 25 through what is it, 32 all, the calculator one. So sine theta is positive in quadrants 1 and 2. The calculator is going to give you this angle, and you need to find this angle also. Okay? So when you input inverse sine of 0.4, you get theta 1 equals 0.41, because they want it rounded to 2 decimal places. And theta 2 is pi minus theta 1, which when you put that into the calculator, you get 2.73. And so these are the two answers right here. Alright, so number 26 is cosine theta is 6/10. So we know that cosine is positive in quadrants 1 here and 4. So we need angle theta, which the calculator gives us. And then we also need theta 2 right here in quadrant 4. Remember, this angle and this angle are congruent. So then to get the green angle, you take 2 pi minus theta 1, which is what we got up here. Now when you calculate this angle, don't use 0.93. Use all the numbers that you have on your calculator. So just put in 2 pi minus theta 1, not just 0.93, but all the digits. And then that'll give you the answer that you round off to the nearest hundredth. So number 27, we know tangent is positive in quadrants 1 and 4. I'm sorry, 1 and 3. The calculator is going to give you the first angle, the one in quadrant 1. To get the second angle, we just add pi. Okay, to get from here to here, we just go add pi. And you see the work right here. So this is inverse tangent of 5. And then I just added pi to that number there. So remember, I kept the whole digit, like all the digits on the calculator, and I just added pi. And then that's what you get when you round. For number 28, first we convert it to its reciprocal function, so it's tangent. And then when you convert it to its reciprocal function, you also have to take the reciprocal of the number. So the reciprocal of 2 is a half. So you put this into the calculator. We know tangent is positive in quadrants 1 and 3. So it's just like number 27, inverse tangent of 0.5, and that gives you 0.46. And then to get this angle, all we do is add pi to this angle. So from here to here, we add pi. And there's the second answer. For number 29, cosine is negative in quadrants 2 and 3. So the calculator gives you the angle in quadrant 2, and to get the one in quadrant 3, you subtract 2 pi from angle theta 1, because this angle right here is congruent to this angle right here. So we subtract 2 pi. We do 2 pi minus this measurement, which equals this one, to get this one. Alright, for sine theta equals a negative ratio. This is the one that has where you find the smaller angle last and the bigger angle first, just because it makes it easier as you're plugging in numbers. So when you input it as it is like this, you get this angle right here, but in negative, right? So to get this angle in positive, you add 2 pi, and that gives you this. Okay? To get this angle right here, the green angle, you take this value, so the absolute value of what the calculator gives you, plus pi, because up here this is pi, so it's going to be pi plus that little piece right there. So that's going to give you this angle right here. For number 31, again, because it is a reciprocal function, we convert it to its reciprocal. So reciprocal of secant is cosine, reciprocal of negative 4 is negative 1/4. So this is what you input into your calculator. We know cosine is negative here and here. So angle theta 1 is the one you get from the calculator, from inverse cosine of negative 1/4 or negative 0.25. And then the green angle is 2 pi minus this angle right here. So 2 pi minus theta 1. And so here are the two answers. Number 32 is actually it's a cosecant, it's another reciprocal, so you have to find its reciprocal function, which is sine, and the reciprocal of -3 is -1/3. So this is what you put into the calculator. So first you find the bigger angle because it's easier. I think it's more direct, because all you do is you do inverse sine of -1/3 and then add 2 pi to that answer, and that gives you the angle in quadrant 4. For the angle in quadrant 3, you take pi, which is up here, plus the absolute value of what the calculator gives you. So you end up with this angle, which is in quadrant 3. Alright, for 39, it's already factored for you, so I just took each factor and set it equal to 0. So this one just becomes cosine theta is -1/2. This factor gives you tangent square theta is 4. You take the square root and you get tangent theta is plus or minus 2. When you input inverse tangent of 2, you get 1.107. And so you know that if tangent is positive here, it's also positive here. So I added pi, and I got the second angle, 4.249. Then I input on the calculator inverse tangent of -2. That's this angle and this angle. Well, the calculator is programmed to give me this angle in negative, right? Negative 1.107. So I added pi to get this angle, and that's 2.034. I added pi again to come back to this quadrant right here. And so that gave me 5.176. So these 4 angles are associated with this part of the equation, and these 2 angles are associated with this part of the equation. Okay, so these are the 6 angles that make this equation true. Okay, now general solution. Notice I only wrote this one. I did not write this one because they're pi units apart. These 2. Same thing. I wrote this one, but I didn't write this one because they're pi units apart. And then I did write one for each of these because these are not pi units apart. One's here and one's here. And these repeat every 2 pi. So that's why you see 2 pi n after them. For 42, you have a quadratic, and so I factored it right here. This is the factored form. So I took this factor and set it equal to 0, and I got this. This factor set it equal to 0, and that gave me this. So we know that sine is negative in both quadrants 3 and 4. So the angles associated with those ratios for sine are 7 pi over 6 and 11 pi over 6. And then for this angle right here, it's going to be pi over 2. Okay? For the general case, okay, so the general form, because the originals are not pi units apart, I wrote a line for each of them and added 2 pi n, because every 2 pi they repeat. They land in the same spot, so I have to add another 2 pi to get back here. Same thing for this one, and same thing for this one. Alright, so for 45, you factor like you would any quadratic. So I use the box method. You can use whichever method you like to get your factors. So this 2 minus 1 tells me that one factor is 2 cosine theta minus 1. And this 1 minus 3 tells me that the other factor is cosine theta minus 3. And so you set each equal to 0. Cosine theta is positive 1/2. Cosine theta is 3. So we know cosine is positive in quadrants 1 and 4. And over here on this side, this is not possible because this number here is bigger than 1. Remember, cosine and sine are both between -1 and 1, inclusive of the ones, positive and -1. So 3 is bigger. This part has no solution. So the angles for the first equation are pi over 3 and 5 pi over 3, and that's it. Over here, since they are not pi units apart, we write a line for each of them, and we add 2 pi n. For number 48, you have another quadratic, so you find factors of -24, and you get -24 by multiplying -12 and 2. That add up to 5. So here's the pair, 8 minus 3. Again, x factor or in a box, whichever you prefer. So these are my 2 factors. You see them right here. When you solve for sine theta in each of the factors, first one you get 3/2, the second one you get -4. Well, 3/2 is bigger than 1, so this is no solution. and negative 4 is smaller than negative 1. So this is also no solution. So this equation has no solution. Alright, 51 is already factored for you, so you just have to set each factor equal to 0. And you see that right here in this, here and here. So we know cosine is 0 at pi over 2 and 3 pi over 2. We know sine is negative in quadrants 3 and 4. So the answer for the first equation would be pi over 2 and 3 pi over 2. And then for the second function, or the second equation, okay, so the second equation gives you 7 pi over 6 and 11 pi over 6. So these are the four angles that give you solutions in the equation between 0 and 2 pi. Now for general solution, pi and 3 pi over 2 are opposite each other, so you just have to put pi over 2 plus pi n, and that takes care of those two. And then 7 pi over 6 and 11 pi over 6 are not across from each other, so they each take on their own line here, and 2 pi n instead of pi n. Okay, but remember, since these are opposite of each other, you just write it once and then pi n. Alright, so we factored out the sign from both terms, and you're left with this here. Set each one equal to 0, each factor, so this factor and this factor equal to 0, and then you solve for the trig function. So right here it's just sine theta is 0, right here tangent theta is negative 1. So we know that sine theta is 0 both here and here, and tangent theta is negative 1 here and here. So the answers between 0 and 2 pi here for this part are 0 and pi. The answers here are 3 pi over 4 and 7 pi over 4. So these are the only four answers in this interval. The general solution, I take 0 plus pi. I could do, start off with 0, so 0 plus pi n is just pi n. You don't have to put 0 plus. Okay, so this is enough. And then I'm going to take this answer, and because this one's across from it, you just have to write that one. You don't have to write 7 pi over 4. And here's the solution for that.